Welcome to this explainer. Okay, I want you to imagine just for a second looking up at this absolutely breathtaking image of a galaxy. You know the kind, right? You've got those iconic swirling arms of starlight, these vast glowing nebula, and that blindingly bright, densely packed center. Honestly, it feels like you're seeing the entire universe laid bare. But what if I told you that you're barely seeing any of it? Seriously, the absolute most massive part of the galactic structure, the heavy, looming giant that is literally holding all of those glittering stars together, is entirely invisible to us. It's a cosmic paradox staring us right in the face. So today, we're investigating this mystery of the unseen. So, how do we study the most massive part of a galaxy if we can't even see it? I mean, it sounds completely impossible, right? Think of this explainer as a cosmic detective story. We are basically on the hunt for a suspect that operates entirely in the shadows, leaving absolutely zero visual trace. And we're not just talking about some cloud of dust blocking our view here. This matter doesn't interact with the electromagnetic force at all. No light reflects off of it, no energy is visibly emitted by it, it doesn't absorb radiation. Even our most advanced telescopes cannot snap a picture of it. If you were to shine a laser right at it, the beam would pass straight through as if nothing was even there. Yet, we know with absolute mathematical certainty that it is there, just quietly dominating the cosmos. Okay, let's dive right into this. Section 1, the invisible galactic giant, or as I like to call it, the unseen majority. Allow me to introduce you to our prime suspect, the dark matter halo. This is the most massive part of the entire galactic halo. But here is the kicker. The true paradox of this whole cosmic structure is that it cannot be observed directly. When we think of a galaxy, we usually picture this flat, spinning disk, right? Kind of like a glowing record floating in space. But the dark matter halo is completely different. It's this vast, spherical envelope that totally encapsulates that flat disk. It is the heaviest, most dominant architectural feature of the galaxy, and yet it is completely hidden from our eyes and our instruments. We're dealing with an invisible giant that dictates the fundamental rules of galactic evolution, shaping the universe as we know it, all while stubbornly refusing to step into the light. Moving on to Section 2, Clues from Gravitational Effects, Catching the Unseen Suspect. So, if we can't see it, how do we actually know it's there? Well, as lead investigators in this mystery, we need to stop looking for a mugshot and start looking for footprints. We catch our suspect in 3 precise steps. Step 1, we observe gravitational effects happening out in space. Since this invisible suspect doesn't interact with light, its only calling card is gravity. We just watch how visible objects are moving and interacting under that gravitational pull. Step 2, we run the numbers and realize that the visible matter, the stars, the gas, the dust we can actually see and weigh, well, it simply cannot explain the sheer force of those gravitational effects. There just isn't enough physical stuff there to cause what we're seeing. Which leads us to step 3. We infer the presence of the dark matter halo. We deduce its existence not by seeing it, but by measuring the profound, undeniable physical impact it has on literally everything around it. Now, what's really interesting about this slide is these specific clues left behind. Astronomers infer the presence of the dark matter halo through these massive astronomical behaviors, specifically the motion of stars and the rotation of galaxies. When we look at how fast stars are whipping around the outer edges of a galaxy, the behavior is deeply suspicious. This case was actually famously cracked wide open by astronomer Vera Rubin back in the 1970s. She was studying the rotation curves of spiral galaxies. Now, according to the standard laws of physics, the stars at the far outer edges of a galaxy should be moving much slower than the stars near the densely packed center. Kind of like how Neptune orbits the Sun much slower than Mercury does. But that is not what happens. Instead, Rubin found that stars at the far, tenuous edges of a galaxy were zooming along at mind-bending speeds, often upwards of 220 kilometers per second. They were moving just as fast as the stars right near the galactic core. To truly understand the sheer scale of this discrepancy, we have to look at the limits of visible matter. The stars, the gas, the dust, They are totally insufficient to explain the gravitational effects alone. If we rely strictly on the gravity provided by the visible stuff we can actually tally up, those outer stars are moving way too fast. In fact, they're moving so fast that they should be violently flung out of the galaxy entirely, just shooting off into intergalactic space. The gravity of the visible matter just isn't strong enough to hold on to them. And that is exactly where the dark matter halo comes in. It is the inferred presence that makes the math work. To keep those fast-moving stars safely tethered to the galaxy, the universe requires about 5 to 6 times more mass than what we can actually see. The dark matter halo essentially balances that immense deficit. It provides the hidden gravitational mass required to explain the dramatic, high-speed motion we're witnessing. Which brings us to Section 3, bound together by dark matter, the cosmic glue. So what exactly is this invisible suspect doing out there in the dark? Well, the staggering reality is that the dark matter halo extends much, much farther than the bright parts of the galaxy, and this brilliantly illustrates the sheer scale of it. When you picture the Milky Way, you probably picture that bright, glowing disk of stars, right? Well, that visible disk is roughly 100,000 light-years across. That feels absolutely massive to us, but it is just a tiny fraction of the galaxy's true footprint. The dark matter halo actually forms a colossal invisible sphere around that disk that extends for hundreds of thousands, sometimes up to 1,000,000 light-years in every single direction. It completely dwarfs the brilliantly lit parts of the galaxy we usually admire. It's vast, sprawling out into deep, freezing space far beyond where the last traces of starlight fade. So, the crucial point is this. The dark matter halo is the key reason galaxies stay gravitationally bound together. It's the cosmic glue. Remember those exceptionally fast-moving stars and rapidly rotating galaxies we just talked about? Well, without the immense, overarching mass of the dark matter halo providing that invisible gravitational grip, the entire galaxy would simply dissolve. The visible matter would be violently flung out into the total emptiness of space, scattering stars and planets to the cosmic winds. Actually, taking it a step further, without the deep gravitational wells created by dark matter in the early universe, galaxies might never have cooled enough gas together to form in the first place. We literally owe the very structure of our galaxy, and, the fact that we have a stable solar system to call home, to a giant we can't even see. So we've tracked down our suspect and discovered that the heaviest, most vital part of our galactic home is a phantom. It's entirely unobservable, but absolutely essential to our existence. Honestly, it makes you look at the vast expanse of the night sky completely differently, doesn't it? Just knowing that the real bulk of the universe is wrapped in darkness. Which leaves us with this final thought. If the very thing keeping our galaxy bound together is completely invisible, what else in the universe is hiding in plain sight?